So in case of pulley, these are the most common situation, like a string attached to attached with two particles, particle A and B. So these two particles are connected together by one single string which passes over this pulley. And when you release the system, suppose the mass of this is 3 and mass of B is 4, in that case that's heavier, so this will go down and that particle A will go up. So that's the kind of movement we have to deal with for this first position, first scenario, in which it's just the string is passes over the pulley and two objects are connected to this string. Situation 2 actually deals with, like they will mention that there is this table, and at the corner of the table, at the edge, we have one single pulley and the string passes over it. So this particle actually is placed on this surface. It will move in this horizontal direction and this one will move vertically. The third situation, as you can see, the plane is just inclined, so at the edge we have this pulley, the string is connected, one particle is hanging here and another one is here. So the direction will be mentioned sometimes in the question. So if particle P goes down, in that case Q will move up, or vice versa, Q might move downward, in that case P will move upward. In this situation, both of the particles are on inclined plane. So the example I have selected here in this, one of the plane is smooth, so we do not need to consider any frictional force in this case, whereas the other one is rough, so we have to consider the frictional force. Both of the particles are on this inclined plane. So suppose A will move down the plane, in that case B will move up. That's another situation where B might move down and A will move towards left. So like I said, there can be other situations, but these are the most common ones. Actually, this is type 1, 2 and 3. These three are the most common. So I will cover type 1 now. Okay, so this is the situation where this particle A and B, let's assume the mass. Suppose the mass of A is 4, suppose, and mass of B is 3. In that case, initially they are connected by this one single string, so that's why they will move simultaneously. Since it's one string, it means when A moves down, at the same time, with the same speed, B will move up. That's the thing. And since as you can see, A is heavier, in that case the movement of A will be in this direction and B will move up. So in this one, the thing is, since they are moving in different direction and all, it's always better to draw two different free body diagram for each of them. And the thing that is constant in this whole situation is the tension inside the rope. Since it's one single string, so there will be only T. Okay, you cannot just use T1 or T2 because this is only one string. So that's why it's the tension which is actually inside this rope, that the internal force. So as you can see, for particle A moves down. Okay, so let me just introduce the forces here. Weight of particle A is 4g, right? Weight is mg, mass is 4, so 4g. That will obviously act vertically downward. Similarly, for particle B, weight will be 3g. So no matter in which direction they move, weight of the particles will always act down the plane, vertically downward towards the earth. Okay. And what about the tension? The tension always acts away from the body. That's the shortcut. Like if you really do not want to spend any time thinking about the direction, in that case you can use this shortcut, that tension always acts away from the body. Okay, the arrow will go outward. That's the shortcut I use when I do not have much time to think about the direction. But then again, I will explain the logic behind it. Suppose particle A is moving downward, but still it is going to feel a force in this direction because it has to pull particle B, right? Since it has to pull particle B, it is actually feeling a force in upward direction. It's trying to go in downward direction, but still it will feel a force in upward direction. Besides, the rope is actually holding this particle A, right? So the tension has to be in upward direction, and as you can see, it acts away from the body, so it matches with this situation, right? It goes up. If you draw in this direction, in that case it's towards the body. And besides, it's a rope, it's just a rope. Suppose you just take a bag, if that's the handle of the bag. If you just hold this bag, common sense, it's normal basic knowledge, if you are holding something, it means you are actually giving an upward force, right? The weight of the bag is downward, so you are just giving an upward force. So anything which is hanging, you are just holding it, it means you are just giving an upward force. That's it. So that is what happening here. So for particle A, the tension acts in an upward direction, and for particle B, when particle A is moving downward, B will move upward. So B will have a force that will pull it in this direction. So that's the tension. So tension acts away from the body. As you can see, it's outward, away from the body. So one single rope, P is moving downward, B is moving upward. A is moving downward, simultaneously B is moving upward. Both of them are moving at the same speed, same velocity. Okay, so that's why they will have the same acceleration. So for this situation, T and A are common for both the particle. So while solving this math, you just break down this thing into two different free body diagram. Suppose when you're working with A, downward is positive. If downward is positive, in that case, if you apply F equals ma, 4g is positive, T is negative, equals 4a in 4a. Mass is 4, acceleration is a. That's the equation for particle A. B is moving upward, so I will take upward as positive for B. Always take the direction of motion as positive. It makes the math easier to solve. So B is moving upward, so I am taking upward as positive. So for B, tension is positive, weight is negative, equals ma. So that's the equation for particle B. So that's all about the theoretical part for pulley. Then I will solve a few example math. So basically, whatever the unknown is, whether it's tension or acceleration or mass, you just have to write two different equations of motion for these two particles individually and then solve the simultaneous equation. That's the basic. No matter what the arrangement is, whatever the arrangement is, the basic idea is you just introduce the forces into the diagram, you select the direction of motion, and then you just apply F equals ma for both of the particle. You will get two different equations, and for that you use two free body diagram of both the particles. So you can take a screenshot of this. I will solve example number 1, and mass of P and Q are given 2m, 3m in terms of m, and as you can see, they are connected to a light inextensible string. So that's when this that answers your question, that tension is constant. Yes, the pulley is smooth. They will also mention that this pulley is smooth. So that's why we are not considering the friction. In real life, there will be friction. No matter how much you try, there will be friction and loss of energy. But for the time being, in math, they will mention that we are considering smooth pulley. So there's no friction. So that's why we can assume acceleration is constant, tension is constant. So these are just the assumption. That's it. Okay, so let me continue with this one. Light inextensible string, and that's why we are not even considering any weight of the string or something. We are just focusing on the objects. So particle P has a mass of 2m, particle Q has a mass of 3m, and they are connected to the light inextensible string. The string passes over a pulley, and the masses hang with the string taut. the system is released from rest. So when the system is released from rest, this Q is heavier, the weight is 3 mg, and that's 2 mg. So since it's heavier, so that's why Q will move down. I will take downward positive for Q, and P will move up. I will take upward positive for P. And whatever the tension always acts away from the body. So T is upward, T is upward. So we need to find the acceleration, we need to find the tension. That's the most common question. Along with that, they will ask you about the later motion, like the string might break, P might hit the ground. So for the time being, I'm skipping those parts. I'm just focusing on finding tension and acceleration so that it's easier to grasp the concept first. So I will write two different equation of motion for particle P and for particle Q. So let me start with P. No, wait, let me start. Okay, it doesn't even matter. So let me start with P, and then I will take Q. Okay, so P is moving upward, so that's why upward positive. So F equals ma. T is positive, 2 mg, equals mass is 2m, A is unknown. So A and T, we need to find those values, A and T. So for particle Q, you need to take downward as positive since it's moving downward. So F equals ma. So downward is 3 mg. Tension is upward, so negative. M is 3m. So for this one, I always just subject T because we have coefficients with A, right? So it's always easier to subject T. So I subject T from both the equations. So 2 mg, 2 ma. That's my first equation. And from the second one, if you subject, you shift side and change the sign and all. So the final line will be 3 mg minus 3 ma. So these are the two equations. As you can see, we have to find T and A, but still we have a third variable m, but eventually it will be cancelled out from both the sides. Okay, so let me just, that's equation 1 and that's 2. So if I equate both the equations, I get 2 mg 2 ma. At the right side, I have 3 mg 3 ma. So if you just factorize this thing and take m from both sides, cancel it out from both sides, you get 2g 2a, 3g 3a, and then it's 5a g. So a is 1/5 of g. So once you get the value for a, you can substitute the value of a in both the equation or any of the equations to get the value for T, which will be obviously in terms of m. Okay, the value for tension will be in terms of m. So you substitute the value of A to get the value of T, which is the tension. So that's example number 1. So let me start with example 2. So the particle have mass 3 kg and mg, where m is less than 3. So it's already mentioned that m is less than 3. It means this is heavier, so this will go down and this particle will go up. So let me just name them, that's A and B. So weight is 3g, weight is mg. Tension is obviously away from the body, so that's why T is upward. So that's all about the forces here, and they're attached to the string of a light inextensible string. The string passes over a fixed smooth pulley. The particles are held in position with the string taut, and the hanging parts of the string is vertical. We are assuming that it's vertical. The particles are released from rest, so initial velocity is 0. the initial acceleration of each particle has a magnitude of this. So it means we already know the value for acceleration. So we know the value for A. So find the tension, find the value of M. So we need to find T and M. Okay, so if I start with this one, in that case we do not know the value for T, we do not know the value for M. So it's better to start with A, because here we know the value for M, right? So if I consider particle A, it's going downward, so I will take downward as positive. So F equals MA. So weight is downward, that's the direction of motion. So I'm taking 3G minus tension equals MA. M is 3. M is 3. A is given. So 3 by 7G. So if you just solve this equation, you will get the value for T, which is 3G minus 9 by 7G. So that's tension. So for M, we actually eventually have to come to this particle B. So B is moving upward. I am taking upward positive. So tension will be positive, value of which we know, we can substitute that. So T minus mg, which is the weight, equals MA. M is unknown. A is given 3 by 7 G. So from here we have to find the value for M, right? We have to find the value for M. So T is 3, and that's 12 by 7G. So 12 by 7G minus mg, 3 by 7 mg. Since we need to find the value, first of all you can cancel out all the g. So you are left with 12 by 7 minus m, 3 by 7 m. So since we need to find the value for m, you can shift m there. So that's 1 plus 3 by 7. So 10 by 7 m equals 12 by 7. So you can cancel out 7 and get the value for m, which is 1.2. So that's the solution of example number 2. Let's solve the next one. We have two particles A and B. Masses are given 4g, 3g. So mass are 4 and 3 kg. So weights are 3g and 4g. So 4g, 3g. Tension acts away from the body, so that's why tension is upward, and we need to find the tension. The particles are released from rest. We need to find the tension, and then when A has traveled, so that's part B. So this math is lengthy. This is quite lengthy. Part B will be lengthy. Okay, so I will just form two equations for particle A and B and solve that. So 4g, 3g, so A, that's A and B. So A will move downward, B will move upward. If you consider the free body diagram, you can get the equations for both of them. So for particle A, okay, so for particle A, F equals MA. So A is moving downward, so I will take downward as positive, and B will move upward. Okay, so 4G will be positive, tension will be negative based on our selected direction. So 4G minus tension equals 4A. So from here, if you subject t, you get 4g minus 4a. That's the first equation. Similarly, for particle b, b will move upward. So tension will be positive, 3g is negative, equals ma, mass is 3, a is unknown. So from here, if you subject t, you will get another equation. So that's the second equation. So if you solve this equation 1 and 2, you will get the value for acceleration, and then eventually you will get the value for the tension. So if I equate this thing, 4g minus 4a, 3g plus 3a. So if you solve this one, you will get 1 by 7g, which is basically 1.4. Let me check. Yes, and when you substitute this in any of the equations, suppose I'm substituting in this one, 3g plus 4a, this will give you the tension, which is 33.6 Newton. So I'm done with the first portion, part A. This was similar to the example math I have solved, but part B is the extra portion, like what happens after this starts moving or one of them stops moving. So that's the trickier one, tricky part. So let's solve that one. When particle A has traveled a distance of 2 meters, it strikes the ground and immediately comes to rest. So they're talking about particle A, that if that's the ground level, particle A will move 2 meters, and it will hit the ground and it will come to rest. So that's particle A at the floor. So this distance is 2 meters. Assuming that B does not hit the pulley, find the greatest height B reaches above its initial position. This is the initial position of B. When A moves 2 meters in downward direction, simultaneously at the same time, particle B will move vertically upward 2 meters. Obviously, they will cover the same distance. So let me just clean this stuff. Okay, so the situation is when A is moving downward, B is moving upward. So this is where B is just when particle A hits the ground. So what happens after that? So let me just solve something from here. For particle A, the whole system starts from rest, right? It is already mentioned that the whole system starts from rest. So I'm working with particle A. Then I will come to this particle B. Okay, I'm not discussing this one. Let's focus what happens to A. Initially, U is 0 for particle A. A was moving downward with an acceleration of 1.4. So you know the value for U, you know the value for A. It will cover a distance of 2, so S equals 2. So we can find the velocity with which A hits the ground. Okay, we do need that value because that with the same velocity we will continue its motion, right? So that's why I have started working with particle A, and I'm trying to find the final velocity of particle A. So V equals U square 2AS. So from here you'll get √35 divided by 5. So that's V. So the thing is, particle P hits the ground, particle A hits the ground with a velocity of 2√35 by 5. So at the same time, B was moving with this velocity, right? But when A hits the ground, it is no longer moving in this direction. So that's why B will no longer feel any force that will pull it in upward direction. The thing is, B is moving upward because A was going downward, right? So when A hits the ground, it's no longer moving in downward direction. it just stops, but B still continues to move because of inertia of motion. Inertia is something that it continues in a direction of motion. It cannot just stop suddenly. It continues the motion. So when A hits the ground with a velocity of this, B was moving with the same velocity, 2 root 35 by 5. So the point is, in this situation, when A is no longer moving in downward direction, the string becomes loose. The string slacks. So tension equals 0. The thing is, suppose this is you and that's your friend. You are holding one single rope. It's a rope or a string. So if you go towards right, your friend goes towards right. If both of you are moving with the same velocity, the string remains tight, right? But the moment when this person stops moving, but this person goes towards right, that's when the string becomes loose, right? It means the distance has to be constant. If the gap decreases, in that case, the string becomes loose. It's just basic common sense. So that's what happens here. So when the string becomes loose, there's no tension. It's not tight anymore, right? So there's no tension. Tension equals to 0. So that's what happens here. When A hits the ground, it's not moving in downward direction, and it just stops moving because it is at this point where it cannot move. It just hits the ground. So that's when the string becomes loose and tension is 0. So that's why the acceleration we solved is no longer applicable anymore, because that's the acceleration because of the motion because of the tension in the string. So if that tension is not applicable, in that case you cannot use 1.4 anymore. Okay, so what happens is that B was moving even though it is not having a force that will pull it in upward direction, but still it cannot just stop suddenly. Suppose it is moving with a speed of 10, you cannot just stop suddenly. It will take 1 second or 2 seconds, no matter how small time duration it is. It takes a few seconds to stop, right? So by that time duration, by the time it stops, it will already cover a small distance. We are trying to find that distance. So it was moving with this velocity. So for particle B, u is actually that, the same velocity with which A hits the ground, because that's the velocity with which B was moving, right? So u is this one. It will just slow down because it is no longer have this acceleration. It will just decelerate. It's normal free fall, acceleration of free fall, because tension is not applicable. It's just the weight of the object part, because there were only two forces, tension and weight. So if tension is not there, it's just the weight. So it's normal vertical motion, the thing we solved. You just project something, it falls down. That's the thing happening here. So it's just free fall, so it will decelerate. So A is minus 9.8, and it will move a small distance and then it will come to 0. It will come to rest. So V is 0. So if you solve this one, V square U square, if you square this thing, you will get 28 by 5, 2as. So from here you will get the value for A, which is value for S, which is this red portion. But we have to solve the value for the distance, the height B reaches from its initial position, right from here, from its starting point, the total distance. So 2 plus this red portion. So total distance is basically 2 plus 2 by 7. So 2 by 7. Okay, so 2 by 7 is your total distance traveled by particle B starting from its initial position. So I know this is tricky. It's just there are different parts. You need to just work step by step. So that's why I have solved 2 example math. So I guess now it should be clear enough to solve extra math that is based on this type of concept.